Good evening, everyone. I wanted to put together a quick video to go with the notes um, for your shifts that I just loaded on Google Classroom and go through a few practice problems on Khan Academy so we can see how they go together. Okay, so I'm going to share my screen with you. All right, so let's get that out of the way because we want these things here. Here we go. Here are the notes that I just loaded into Google Classroom for you. So we see that a shift is a slide or a translation. It keeps the same shape and same size. It doesn't change it. Doesn't even change its orientation, meaning it does not reflect it. It just moves it to a new location. So it's going to slide it left or right or up or down. Okay, if it's horizontal, it's changing your x values because the x's are the left and the right on the coordinate plane. And we're going to see that change happen inside the function. If it's a vertical change, it changes your y values because remember, y values tell you how far up and down you go, and we're going to see that outside the function. We are going to know that it is a shift when we see something that's being added or subtracted. Okay. Want to remind you, because we've done these before, that when it's horizontal, it's always going to do the opposite. So when it's a minus, it moves right, and when it's a plus, it moves left. But for vertical changes, they follow the sign. So when it's a plus, it moves up, and when it's a minus, it moves down. So over here, I have one of the practices from the Khan Academy. So let's see what we have. The graph of y equals h of x is a transformation of y equals f of x. This is the transformation of this one. So we started here and went to this one. Okay. They want us to write the formula for h in terms of f. Now we know that the function was just f of x. So let's write in f of x. Nothing different there. Now, this is not a guessing game. It's really not. We want to find an important point that is the same point on each graph, and we want to see how it moves. And so we can use this vertex right here. If I start here and go to here, let's see what happens. I have to first move to the right. So let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it was 12. I had to move to the right 12 jumps. Now remember, when it's moving to the left or right, it's horizontal, and horizontal is inside the function. And because I want to move to the right, it's going to be a minus. So watch this. I'm going to go down to here. I'm going to go inside the function, and I'm just going to put my minus 12. Okay? Again, inside is horizontal, and it's the opposite. I wanted to move right, so I have to make it a minus. Now, again, I went from here. I moved to the right 12 jumps. Then I have to move, it looks like down. So let's count that. 1, 2, 3, 4. All right, I moved down. That's a vertical. It's going to be on the outside of the function, and because it moved down, it means it's a minus. So I'm going to go to the outside of my function and put my minus 4. All right, let's check it. Boom, we did that. Perfect. Let's look at the next one. I'm sorry if I'm talking fast. This is the second time I've done this video. The first one took too long, so I'm trying to keep it a little bit quicker. Okay, same idea with this one, okay? The graph of y equals g of x is a transformation of the f of x. So this was our original graph. This is the one that it moved to. It is telling me that f of x is equal to the square root of x plus 4 minus 2. Well, I want you to look at, so let's go down here and let's do the square root of x plus 4 and then our minus 2 on the outside. So I haven't done anything to this yet, okay? Now let's see what happens. We have to go from this graph to this graph. So let's pick an important point, and I think this is the easiest one to do. So I have to get from here to here. So let's count our left and right first. It looks like I need to go 1, 2 jumps left. Remember, when it's left, it's 2 jumps. Okay, so it's going to be a plus, and it's going to be inside. So I'm going to go inside the function that's right here, and I'm going to put a +2. I'm not done with that yet. We'll come back to it. Okay, so now we were right here. Now let's see what we have to do. I have to go up. 1, 2, 3, 4, 5 jumps up. Okay, when it's up, it's on the outside, and because it was up, it's going to be a plus. So I'm going to go to the outside, and I'm going to put +5. Now this whole thing looks messy, so let's make this look just a little bit better. I can combine a +4 and a +2, and all together I can make it +6. And I can combine a -2 and a +5 and make it a +3. All right, so let's check that and see how we did. Fingers crossed. Beautiful. All right, let's do one more together. Oh, good, this was one I wanted. This is the graph of the square root of x. Okay, that's what the graph looks like for a square root function. They want us to find this graph. Now, I don't have anything added or subtracted on the inside, so it's not going to move up or down. It's going to stay right where it is. So this point is going to stay here, almost. But this, it's on the inside. That tells me it's horizontal, and it's a +1. So that means it's going to move left. So I'm going to go from here, I'm going to move left 1 jump. Ooh, right there. Perfect. I want to find a graph that does this. So let's see what we have. I don't agree with A because A moved to the right. Remember, we have to go left. It could be B. I agree, it went 1 jump left, but we should look at the other ones. This one went 1 jump up. Nope. And that was 1 jump down. All right, so B it is. Boom. All right, let's look at this last one really quick. Let's see what they give us. Ooh, this is an ugly one. The graph of the function -1/4 x squared is shown on the grid below. That's this one right here. Okay? See where this is a negative? That meant that it flipped this over the x-axis. It wants us to graph this equation here, -1/4 x + 3 squared. So let's first make this match that. So instead of being at 5, 5, this point is going to be at 5, -5. Oh, -4, there we go. Oh, I'm 1 over, that's why. -5, come on mouse, work with me here. Okay, so it's right on top of that. Because when I look, the only thing that changes from this to this, look, the only thing that changes is this +3 here on the inside. It's inside, so it's a horizontal, it's a left and a right. And because it's a plus, it has to move 3 jumps, ready? 3 jumps left. So I have to move, now watch, if I move this 3 jumps left, see how when I move it back and forth, it's changing how far open and closed this is? Now that's okay. I'm going to put it right back here real quick. I want to move this 3 jumps left, so I'm going to put it right here. Then I'm going to come down, and I'm also going to move this 3 jumps left, because everything moves 3 jumps. It's a shift. All right, so let's try it. We go 1, 2, 3, and then 1, 2, 3. All right, let's check it. Again, it was a shift. It moved everything. So not only did I slide that over 3, I slid that over 3, and we did it. Okay, now what I would like you to do, again, I apologize I'm going fast, but I want to make sure I got in 4 questions so you could see all of them. I would like you now to pull up the notes again, take a look at those, and try to practice on Khan Academy for the shift functions another time or two and see now if you can put it together, because I'm willing to bet you probably forgot some of those things. And that's okay. It happens. It's been a while. But now see what you can do. Okay? I hope you all, wish you all the best of luck. My next video will be on scaling, so keep an eye out for that. That's for this week's work. All right? Bye-bye.